Hello class, welcome to today's lesson. Our topic for today is naming of binary compounds. How are we going to name these binary compounds when the elements are being given? Now, in our previous lesson, we said binary compounds are compounds that consist of only two elements or only two different elements. So how are we going to name these binary compounds when only their element names are given? Example, when you are given sodium and chlorine, how are we going to name this as a binary compound? Before we continue with our lesson, don't forget to hit down the subscribe button to subscribe to my channel so that whenever I make a new video, you are going to get a notification. Let's look at these two elements. Now, if you want to name any binary compound, now the first step you should take is, now you will have to identify the element present in the compound. Now, the first element is sodium. The second element is what? Chlorine. Now, the next step is you will have to write the chemical symbol for this element that combine to form the binary compound. Now, the chemical symbol for sodium is Na, and the chemical symbol for chlorine is Cl. Now, don't forget, in an ionic compound, the atom that forms the positive ion is written first, followed by the next one. So this is an ionic compound. Why is it an ionic compound? Because it contains a metal and a non-metal. Now, we said for the electronic configuration of sodium, it is 281. Now, this means sodium on the periodic table is having atomic number of 11. Sodium is having an atomic number of 11. Chlorine is having an atomic number of 17. Now, the electronic configuration for sodium will be 281. Chlorine, 287. Making up to 17. 281 making up to 11. Now, the next step is sodium will what? Will donate 1 to become positive. Na plus, which is sodium. Now, sodium will lose this 1 to become positive. Now, chlorine is 287. Chlorine needs 1 to become stable. We are saying that first shell should take how many? 2. Second shell, 8. Next shell should also take 8. But this is 7. How many more is needed to obtain 8? That is 1. Chlorine will gain 1 to become negative. Then chlorine is Cl minus. The next step is we what? We know the valency of sodium and chlorine. Valency is the combining power of an element. It refers to the number of electrons an atom loses or gains in a compound to form different elements. Now, this is the sodium. Sodium will lose to become positive. Chlorine will now gain to become negative. Now, this means the valency of sodium is 1. It means sodium lost 1. Now, chlorine here gained how many? Gained 1. That is the valency of this sodium and chlorine. with a different element. This is sodium, this is chlorine, so they are different elements. Now, let's continue with how we are going to name this. Now, we will do what we call exchange of valency. We will write our sodium here. This is sodium, sodium here. This is chlorine, chlorine here. Now, we will exchange their valency. Now, for valency, it is having no charge. Valency has no charge. So, we ignore the charges, plus 1 minus 1. We take it as both positive. So, 1 here, 1 here. This will give 1 to this. This will also give 1 to this. Now, Na1Cl1. Because they are 1, 1, we don't write it, so we get NaCl. Now, for ionic compounds, we name the metals first. We name the metals first, followed by the non-metals. And for the non-metals, we change their last word to IDE. Now, chlorine will now change to chloride. We mention the name of the metal first, which is sodium, then followed by the non-metal, which is chlorine, which will now be changed to chloride. So, sodium chloride. Let's take the next example. Magnesium and chlorine. Now, magnesium is a metal, chlorine is a non-metal. Symbol, magnesium, Mg. Chlorine, Cl. Now, magnesium on the periodic table is having atomic number 12. Chlorine, 17. Electronic configuration, 282. Chlorine electronic configuration, 287. Now, don't forget, all metals, they lose either 1, 2, or 3 of their valence electrons to become positive. Now, this is the valence electron. The last outermost shell contains the valence electrons. So they will lose their 2 to become positive. And that positive indicates that it is what? A metal. Magnesium will now lose 2 to become Mg2+. It means you lose to become positive. You gain to become negative. Now, take for instance, you went to the bank, then you went to borrow an amount of money. Now, you after borrowing the amount of money, you have money on you. You've gained enough money. But don't forget, you will go and pay back. It means you are owing them that amount. So you will definitely go and pay back. You've gained, but you are owing them. Let's continue. Now, chlorine here will need 1 to be stable. 287. Chlorine needs 1 to be stable. This means chlorine will gain how many? Chlorine will gain 1 to become negative. Next step is we do our crossing. Now, the valency of magnesium here is 2. The valency of chlorine here is 1. Chlorine gained 1. Exchange of valency. Magnesium, we write it magnesium. Chlorine, we write it chlorine. Now, we will have to exchange their valencies. Now, don't forget, I said for valencies, we don't include the charge. So, 2. Magnesium will now give the 2 to chlorine. Chlorine will give 1 to magnesium. But for the 1, we don't write it. We ignore the 1. So we are going to get MgCl2. Now, what is the name of MgCl2? We mentioned the name of the first element, which is a metal. So magnesium. Then chlorine will now change to chloride. Now, sometimes you can mention the number of atoms of chlorine, which is 2. When it is 2, we say it is di. When it is 1, we say it is mono. When it is 3, we say it is tri. So we can say magnesium dichloride. Magnesium dichloride. But if you don't want any problem, just ignore the di. You just write magnesium chloride. You are good to go. Let's take the next example. Calcium and oxygen. Calcium is a metal. Oxygen is a non-metal. Calcium symbol Ca. Oxygen is O. Calcium on the periodic table is having atomic number 20. Oxygen atomic number 8. Electronic configuration for calcium 2882. Oxygen 26. Now, calcium will what? Will lose 2 to become positive, Ca2 plus. For the non-metals, they will what? They will gain. Now, they want to be stable, so they will have to what? Gain 2 to become stable. So it is O2 minus. This means 2 more is needed to obtain 8. That's why the first shell takes 2, second shell takes 8, next shell also takes 8. For going that way. Now, O2 minus Ca2 plus. Calcium is having a valency of 2. Oxygen is also having a valency of 2. Exchange of valency. Calcium, Ca, oxygen, O. This is 2. This is also 2. 2, 2, we cancel them. So this is cancelled. We are going to get CaO. Now we said calcium, which is the metal, will be named first, and the oxygen, which is the non-metal, will be followed. Calcium. Now we said for the oxygen, the last words will be changed to ID. So we are going to get calcium oxide. Calcium oxide. Now, for the previous example I gave you, you saw that all their valency were 1, 1, then 1, 2. That is why we never cancelled any of them. But for even numbers, 2, 2, we cancel. 2, 4, we cancel the 2 to be 1, and the 4, you get how many? 2. Let's take the last example. Aluminium. Aluminium, symbol Al. Oxygen, O. Aluminium on the periodic table is having an atomic number 13. Oxygen, 8. Electronic configuration for aluminium 2, 8, 3. 13. Oxygen 2, 6, 8. First shell takes 2. Second shell takes 8. How many more is needed to obtain 13? That is 3. Oxygen, first shell takes 2. 2. Next shell will take how many? So it means how many more is needed to obtain the 8? That is 6. Now, aluminium here will now lose 3 to become positive. Aluminium will lose 3 to become positive. Oxygen here need 2 to become stable. Oxygen 2 minus. Now don't forget, All the non-metals, they have negative, negative. It means they will gain to become negative. They gain to become negative, and for the metals, they lose to become positive. And when they lose, they become stable. And these two, when they gain, they also become stable. This is 3 plus, this is 2 minus. Valency of aluminum 3, valency of oxygen 2, we do exchange of valency. Aluminium here, oxygen down. Now, oxygen 2, aluminium 3. Are you getting it? So we are now going to get Al2O3. We name the metals first. Aluminium, oxygen will change to oxide. Now, others too, they name the number of atoms here. So this is aluminium 2, oxygen here 3. So they can say dialuminium trioxide. Dialuminium trioxide. It means 2 aluminium, 3 oxygen. So dialuminium trioxide. If you don't want any problem, just say aluminium oxide. You are good to go. Now, let me give you a work for you to try. Please, the more you do the work and the examples, the more these ones become very easy for you. So try work. So write the chemical formula. Write the chemical formula of one compound formed between each of the following elements. 1. Magnesium and chlorine. 2. Sodium and bromine. 3. Carbon and oxygen. We will continue in our next video. Don't forget to subscribe to my channel. Thank you all for watching.